Hi everybody, welcome to the self-check section 8.2 video. Let's go ahead and take a look at number one. So number one states, suppose you do a study of hypnotherapy to determine how effective it is in increasing the number of hours of sleep subjects get every night. You measure hours of sleep for 12 subjects with the following results, and we just have 12 individual hours of sleep. Okay, so what we're being asked to do is construct a 95% confidence interval for the mean number hours of sleep for the population. And we want to write an interpretation and sketch a graph. So since we have such a small list of data, we only have 12, what we need to do here is use that t distribution. Okay. And more specifically, since we are just given a list of data, we need to put this list of data into list one. So let's go ahead and do that. So let's go to our calculator and go ahead and go to stat and then edit and go ahead and put your list of data here. I already did, so go ahead and pause the video and put in all that data. Okay, welcome back. So hopefully you have put in your data into list one. So let's go ahead and move forward. So what we need to do here, let's go back to the problem, is construct a confidence interval. So confidence interval is going to be, here we have to use a t-distribution because of our small sample. It's going to be t interval. And since we have a list of data, we need to use the option data. And then we would have to use list one because we entered our data into list one, and then just our confidence level, which is just 0.95. Okay, so once we have our t interval calculator work set up, let's go ahead and put that in the calculator. So here we go to stat, test, scroll down to t interval, and we're using the data option. And the only option we need to change here is our confidence level will be 0.95. Okay, so after we input all these criteria, hit enter, and we get our confidence interval. So 8.16 and 9.80. And notice that we're given the sample mean right here. X bar equals 8.98. We're going to use that when we sketch out the graph. So let's jump back to the notes or the problem, and let's go ahead and write down this confidence interval. So we're going to have 8.16 less than the mean, less than 9.8 hours. Okay, and what I want to do here, just a note for myself, note X bar equals 8.98. Okay, so that's our confidence interval. Let me go ahead and put a box around that. So that takes care of the confidence interval. Let's go ahead and write out an interpretation now. So an interpretation is going to be we estimate with 95% confidence that the true population mean number of hours slept is between 8.16 and 9.8 hours. Okay, that's our interpretation. So it takes care of that part of the question. And now lastly, a sketch of graph. So we want to sketch a graph, we're just going to sketch out our normal distribution. So it looks something like this. And we have our 8.98 as our sample mean. So I'm going to put that in the center, and our confidence interval was 8.16 and 9.8 hours. And so we're just going to shade in between these values. And just give me something that we have 95% shaded region there. Okay, and that takes care of sketching the graph. Okay, let's go ahead and move on to number 2 now. So number 2 states, suppose that 14 children who were learning to ride two-wheel bikes were surveyed to determine how long they had to use training wheels. It was revealed that they used them an average of 6 months with a sample standard deviation of 3 months. Construct a 99% confidence interval for the population mean length of time using training wheels. And once again, interpretation and sketch the distribution. Okay, so let's go ahead and piece through a couple of things we found here. So what we have is 14 children, so n equals 14. It says average of 6 months. Remember, average is the same thing as mean. So we have a sample mean of 6 months. And we have a sample standard deviation that's written with a little s of 3 months. So let me rewrite where it says mean. The different color will say average, the same thing as mean. Okay, and we just have a confidence level of 99%. Okay, so we want to construct a confidence interval. So same setup here. Confidence interval. And that is going to be T interval. And we have to use the stats option. And then for the sake of it, it'll be mean, sample standard deviation, sample size, and confidence level. Just a generic makeup of it. So why am I using T interval? Well, I'm using T interval because I'm given the sample standard deviation. What this means is that the population standard deviation sigma is not known. So I need to use T distribution. Fix this up. T distribution. Okay, so that's why I need to use T interval because we're only given the sample standard deviation. But let's go ahead and carry this out. So I would have T interval, still stats. My sample mean is 6, sample standard deviation is 3, sample size is 4, confidence level is 0.99. So let's jump to our calculator and get our interval. So we're going to the calculator. Let's go back to stat and test. Scroll down to T interval. Excuse me. Add really quick. Okay, welcome back. So we are in T interval and we need to use stats. And we need to use 36, get rid of the 36 and type in our mean, which is 6, and our standard deviation, which is 3, and our sample size, which is 14. And our confidence level is at 99%, so we need to type in 0.99. Okay, so we have everything ready. Go ahead and hit calculate, and we get our confidence interval. So 3.58 to 8.4, rounded up to 2, 8.42. And we already have our sample mean, which is 6. So let's go ahead and jump back to the question. And our confidence interval is going to be 3.58 less than the mean, less than 8.42. And we are talking about months. So that is our confidence interval. Okay, so that takes care of the confidence interval. Let's go ahead and talk about the interpretation of this. So what we would say here is we estimate with 99% confidence that the true population mean length of time using training wheels is between 3.58 and 8.42 months. Okay, so that is our interpretation. Now, lastly, let's go ahead and sketch out a graph. So a distribution of our confidence interval is going to look something like this. Okay, we have our sample mean is 6, so 6 would just be in the middle right here. Our confidence interval goes out to 3.58 and 8.42. And let me space these out a little bit more. So I'm going to say 3.58 and 8.42. The reason I'm spacing them out a bit more is because that's a 99% confidence. So that's pretty much almost our entire distribution. So within here is 99%. Okay, and that's our distribution. So one more question. We have finding a critical value for a sample size of 21 and a corresponding 95% confidence level. And then we want to sketch the t-distribution. So here we have a couple things to take note of. We have our sample size, which is 21. We have our confidence level, which is 95%. And we want to find a t-score or critical value. Okay, so before we even continue with that, one thing I want to calculate first is the degrees of freedom. Okay, so degrees of freedom is our sample size minus 1. So our sample size is 21. So 21 minus 1 equals 20. Okay, so we want to take care of that first, make sure we have all our knowns. But let's go ahead and sketch this distribution, and that'll help us figure out how to calculate this t-score. So here's our distribution. Uh, 0 is always in the middle. That's our mean. And we are looking at a critical value. Recall critical values are always on the right-hand side. And in the middle here, we have 95%. So if 95% in the middle and I'm missing some of these tails on the left and right, I'm missing 5%. So if I'm missing 5% together, these two tails are that 5%. So if we cut the tails in half, we're going to have 2.5% on both sides. So 2.5% and 2.5% to get up to that 100% distribution. So when we try to find a t-score for any critical value in that sense, what we need to do is set it up as our t-score equals. And since we're using a t-distribution, we need to use inverse t. And it will be area to the left and degrees of freedom. Okay, so what's our area to the left? Well, our area to the left is everything from our t-score, our desired t-score, all the way out to the left. So here, this whole middle section is 95%, and then I'm going to tack on that 2.5%. So it's going to be 0.95 plus 0.025. And then my degrees of freedom I found to be 20. So that would be 20 right there. Let's go ahead and clean this up. Let's add up 0.95 and 0.025. So this would be 0.975 and 20. And so if we go to our calculator and calculate inverse t, let's go ahead and check out what we would get. So second vars, inverse t is our fourth option. I need to put in 0.975, comma, 20. And what I get is 2.0859. I'm going to round it up to 2.09. So we get an answer of 2.09. So let's write this out in words. So for a sample of 21 and a confidence level of 95%, we obtain a t-score of 2.09. Okay, so that's it for number 3 t-scores. So that's it for the self-check video. Thank you for watching. I'll see you next time. Bye-bye.